All right, I'm gonna go over 7 now. Also tell me that I may have a typo. I'm gonna go ahead and double check it because I may really. Nicole caught a couple of my typos on this. So let's do number 7 now. Area and definite integral. So a factory is polluting a lake in such a way that the rate of pollutants entering the lake after T month is the rate, guys. The rate of pollutants entering. They're giving you the derivative function, huh? N of t equals 280 t raised to the 3/2 power. T is in month, right? And N of t is a total number of pounds of pollutants in the lake after T month. This is horrible. A, how many pounds of pollutants enter the lake over the first 16 years? Okay. So what they're giving you is, this is actually from this section. We actually went over this section 4.3 just today, right? So if you went through the examples, tried the homework, looked at those application problems, and you're here trying 7, that's wonderful. So we're gonna use definite integral to find that n of 16 is equal to integral from 0 to 16 of that n prime of t dt. So we're going to evaluate that definite integral, 280. Because I think, Laszlo, you got this part, but you were wondering about B. I'm going to go ahead and check it because I may have a typo, who knows. So let's try this together. What I did was, now I think, was this one from my textbook? Like the answers that I typed up are probably from textbooks, and some of them that I left blank are the ones that I made up. So it's good that I go over number 7 just to check my answers that I typed up. Okay, so let's integrate this. Okay, go up by 1. Okay, 3/2 plus 1, right? That's gonna be 5/2 for the new exponent. And I'm gonna divide this by 5/2. But we never do that. We never really divide by a fraction because it just looks bad. Why don't we go ahead and multiply by the reciprocal of 5/2? So we're going to multiply this by 2 over 5, okay? And then plus, no, plus c, right? Not plus c. Because why? We know the bounds for this case, right? What are the bounds? Remember the intermediate notation that you and I talked about in 4.3 video? The bounds are 0 to 16. So let me go ahead and simplify my antiderivative a little bit. What's 280 divided by 5? 56. And 56 times 2 is, oh, whoopsie, 112. 112 t to the 5/2 power. And the bounds that we're going to evaluate are 16 and 0. I love how we got 0 there because if I plug in 16 now, 5/2. If I plug in 16 there, I can find that. But if I plug in 0, because I'm supposed to subtract these values, this second part will just turn into 0. So let me go ahead and evaluate what this is. 112 times, now this is what? Square root of 16 raised to the 5th power, right? And that part just comes out to be 0. So 112 times 4 to the 5th power. I just didn't want to open up my calculator app, but I guess I will because 4 to the 5th power sounds like a big number. 112, where are you, calculator? 112 times 4 to the 5th power. So in the first 16 months, they are putting that much pollutants in the lake. 114, 688. 114. Oh no. All these free apps making me watch these. Now, how do I even stop this music? It's so silly. I'm sorry that you had to watch that. 114,688. Okay. So this is equal to 114,688 pounds of pollutants going into the water in the first 16 months. Ew. Okay. So now let's double check. Is this matching what I typed up in the answer key 114,688? Now that one does. That's good. Now I think the part was B that you wanted to check. So let me go ahead and do part B now. This was part A. Part B, they said, an environmental board ordered the factory to begin cleanup procedures after 50,000 pounds of pollutants had already entered the lake. When was the order issued? Now, what they are giving you is that N of T equals 50,000, right? So that means, and not that means, but what they are asking is at what time, how much. What was the question? When was the order issued? So they're asking for time. And after how many months did they ask them to clean up their mess, right? So what I'm going to do is I know the supply function, or do I know the supply function? You know what? A supply function in general will have like a plus C there. But what we can do is this. Now take a look and see if this makes sense. Okay, I'm going to go ahead and set up something for you. Now, 50 N of T is going to equal to the integral from 0 to some value T, right? Just like how in 16 months, when they ask you for, hey, how much pollutant was in the water in the first 16 months, notice how 16 was the upper limit right there. So I don't know how long it took them to put 50,000 pounds of pollutants in the water, but we know that's going to be T. That stands for T. And then the rate at which the pollutants enter the water, the rate of pollutants entering the lake is 280 T to the 3/2 dt. So this is what we can do. I do know the left side of the equal sign. The left side of the equal sign is 50,000, right? I know the left side of the equal sign is 50,000. So what I'm going to do is I'm going to evaluate. I'm going to try my best to go as far as I can to do this integral, and then see if I can solve for T. Because the only unknown variable is really T here, right? So let's solve it. So leave that 50,000 waiting for just 1 second. But let's go ahead and find the antiderivative here, which I already did, right? So what was it? Let me go ahead and just copy that. 112 T to the 5/2 power, wasn't it? And then what are the bounds here? What are the bounds? The bounds are T and 0. So using that fundamental theorem of calculus, we can say that 50,000 equals 112 T to the 5/2 power minus 112 0 to the 5/2 power, right? Now, it's good news. What's this? That's just 0, right? So what we are solving is this. We're solving 50,000 equals 112 T to the 5/2 power. And we can solve this, right? First, divide both sides by 112. Now, I'm not going to round this problem in the middle of a problem. You know how then we may get like rounding issues. So what I'm going to do is I'm just going to keep that big fraction there. So I will say the left side is 50,000 divided by 112 equals T to the 5/2 power. And to get rid of this 5/2 power, I'm going to go ahead and raise both sides to 2/5 power. Can you move a little bit to the right? Yes. I'm going to raise this side to 2/5 power. So that's what T is. T is going to be approximately 50,000. Well, exactly for right now, because I'm going to go ahead and write that. T equals exactly 50,000 divided by 112 raised to the 2/5 power. And what I'm going to do is I'm going to go ahead and type this into my scientific calculator. And how did they want you to round this? They didn't really say anything about rounding. So I remember in 16 months, in the first 16 months, they put about like 100 and some pounds of pollutants. But if you're looking for 50,000, it's going to be less than 16,000. So let me, hold on. What I'm doing is I'm getting my phone to take a picture of this expression that I'm about to go to the calculator to enter. Okay. Hello, calculator right here. And then what was the expression? Parenthesis. 50,000, yes, over 112, whoopsie, I don't want to close the parenthesis in there, 112, raise that to what power? 2/5 power. Oh, hold on. 50. Oh no, guys, you know what I did? I didn't enter 50,000. I entered 500,000. Oh, that will be really bad. We don't want 500,000 pounds of pollutants in the lake. What are you doing? I just want to go back and change that to 50,000. So let me get rid of 10 over here. Because you know how I knew that was the wrong answer? Because in 16 months, there were 114 some pollutants in the water. So if I'm looking for the month where it hit 50,000, it should be less than 16 month, and I got 28 month. And then when I looked back, I saw that I entered one extra zero there. So here we go. The answer comes out to be 11.478. My goldfish memory span. I'm gonna forget it in 2 seconds. Oh, Laszlo, you messaged. Laszlo, how you doing? All right, so that's my I hit my face with this. All right, so that's my answer. 11.47. Hold on, 479 months. So somewhere after 11 months, they already put, what, 50,000 pounds of pollutants in there. So did it match what I typed up in the answer key for you? Let me see, 11.479. 11.48, yeah, rounded up. So I think what probably happened, Laszlo, was because you may have rounded this mess, like 50,000 divided by 112 in the middle of a problem. And sometimes when you round your answer in the middle of a problem, like your intermediate answers, then maybe you get something very, very, very close. Because the answer that you asked me about was really close. It was like 11 point something, right? So I think that was just it, that you rounded in the middle of a problem. Otherwise, you would have been fine. Just making sure that you show me all this work, step-by-step work on your exam for me. But that was it for number 7. I'll look for your email.